Did you guys manage to do exercise 1 and 2 successfully? Open picture tester and run its main method? You probably can't just open picture tester and run its main method. That's kind of what I should have squeezed in at the end of class to show you, but let me go to my Picture Lab file. If you open, so the instructions say open picture tester. I do want to look at picture tester and show you that there are all these methods defined to do different things to a picture. And in fact, each of these little things is just a runner. It's to test the actual algorithm, which is stored in the method inside the other file. Okay. So when you get to the main method here, the main method of the picture tester class just gives you a setup where you can comment and uncomment different methods to call so that you can test different features that are being added. Okay, so test 0 blue would call this method up here, and this method would create a picture using the beach image. It would do the explore thing, so it gives us all the controls of the window and the mouse clicking and everything. So it's going to put it on the screen. Then it's going to call the 0 blue method on that picture, and then it's going to show us the new version as well. Okay, so now how do we get picture tester to run its main method? We can't just kind of run here. Okay, everything has to be driven by the main Java file. So in order to get picture tester running, we have to come to A5 here and uncomment this code. Picture tester. So we're creating a picture tester object called test runner, and we're just calling its main method. So it will actually do what I just said it was going to do. Open a beach file, zero out the blue, and then show us the file again. Okay, so when I run that, did you guys see that happening? While I'm waiting for this to run, let me just put it out there. Did anybody have any trouble? I know at least one person had some trouble with the file getting stuck. Okay, so there's my Eiffel Tower from here, the first 2 lines. I could comment that out and not show it anymore. But there's the 0 blue. Having been run on this file, it now makes the whole thing look like it has no blue coloration to it. Okay, so if I move these things around, these windows, you can see that underneath is the original beach image a couple of times actually, because I had explored it. Okay, there's the original, oh gosh, I have so many things going on here because A3 is still running. Okay, so if I want to clean up my output, I could just comment out some of these other things in main. I'm done with the Eiffel Tower picture for now. I'm done with the A3 picture explorer. So if I just run it one more time with only the A5 activity picture tester, I should just get the beach and then the 0 blue beach. Here's the beach, there's the 0 blue beach. Okay, so it's basically gone through every pixel and removed all the blue. It's basically set all the blue values of the pixels to 0. So let's take a look at where that happened. Let's see, picture tester calls test 0 blue. Test 0 blue creates a picture object and it calls the 0 blue method. So we should look in the picture file to find the 0 blue method. All right, there's a lot of stuff at the top. I think I scrolled through this and showed you what was in the picture file. There's a toString method that could be used to print out in text information about the picture. That's a familiar thing. Here's the 0 blue method, right? This basically creates a temporary 2D array of pixels, and it gets the pixels from the picture because this is, when you use this keyword, you're talking about a picture object. So it gets the 2D pixels into a 2D array so that it can traverse that array. Each row is being called row array. And then as it goes through each row array, it's going to have going through each pixel and just doing set blue to 0. So that's how this works. The next exercise was for you to play around with it and basically try some of the other methods by commenting and uncommenting the testing, the test methods from the picture tester. So if you have this running the way I do, you can go back to picturetester.java and you could try, instead of 0 blue, let's see, what else could we try? Let's see what else is defined in picture besides 0 blue. There's a mirror vertical. Okay, we'll try that one. It seems to be already fleshed out. So picturetester.java, test mirror vertical. Here we go. And if I test mirror vertical, it's actually going to open not the beach picture, but the caterpillar picture. So I'm not expecting it to mirror the beach unless I change that there. But let me run this now with test mirror vertical, uncommented. There it is. So we have the original caterpillar is underneath, because each one of these methods first explores the image as it is, then it does the change to the image, and then it explores it again. So we have it the original way, and then it's basically a mirrored line. I'm getting a lot of ghosts of the outlines of the windows here, which is not cool, but I can still kind of see what's going on. So you see that the caterpillar has mirrored over from the center. Everything to the left has been copied over to the right using that algorithm right here. Where is it? Under picture.java, mirror vertical. So this is the algorithm that's doing that. It's basically getting a left pixel and figuring out where that corresponding right pixel would be in the grid, and then setting that right pixel to the color of the left pixel, which then makes it look like the same one. And it's going methodically through all pixels on the left side of the image. Okay, so there's a nested loops and stuff like that. These are pretty complicated, algorithms. You can think them through and basically use them as an example to modify to do the other exercises. So that is how you get the things to run, is you go into the picture tester and you comment and uncomment the different parts just in the main method of the picture tester. So 0 blue is there. Your next exercise was using 0 blue as a starting point. Write the method keep only blue. That will keep only the blue values. That is, it will set the red and green values to 0. So once you write that method, you also have to create a static method to test the new method in the picture tester class. So you kind of have to copy the same structure. Be sure to call the new test method in the main method in picture tester. Okay, so I would like to know, raise of hands, visibly, how many of you did accomplish exercise 3? You got it zeroing you're keeping only the blue. 1, 2, raise of hands. 3. Okay. All right, so those of you who have this done, you can just go ahead and continue through the exercises here in A5, but I'm going to stop now and go through the process of doing exercise 3 with the rest who didn't get it done, okay? So that you have an example to work with from there on. So let me go back to my picture lab. If you're having any trouble with Replit not running, Donovan, did you get it back to working?
Yeah, I went on it this morning and it seemed to be working fine.
Okay, must have been their server end. Okay, also, Troy, I noticed that there was a message that you were asking for edit access to my replet. And I denied it because you're supposed to actually fork it so you get your own copy. Then you can edit as much as you want.
All right.
Do you know how to do that?
Yeah, I think so.
Okay, you do have to log in, like with a previous sign in. I just always use Google, like with my school account to log in. And then when you open the replet, you look for the fork. Once you fork it, then you can change things and edit, and then it's not going to change my copy. All right, so I'm just going to demonstrate how to do the keep only blue. Okay, first of all, I'm just going to kind of borrow this 0 blue code. I'm going to copy and paste it and use it as a template for me to change and do something different. So now I'm going to say this is a method to keep only the blue and set red and green to 0. So I'm going to change the name of it from 0 blue to keep only blue. Now this is already a nice structure for me to go through the whole picture. It's got the nested for loops for each loops. But instead of setting blue to 0, basically I just want to set red to 0 and set green to 0. But in order to get this to run, I need to go to the main method of the picture tester class. Picture tester.java. You know, the .java is the one we edit, and then the .class, every file has a corresponding 2 files, right? One says .java, that's the original file, and then the .class file, it looks really cryptic because that's what happened after the Java virtual machine has parsed through the .java class and made it readable as a class file to run. So don't worry about those .class files. Don't delete them. I mean, if you delete them, they just come right back because every time you run, it will recompile and recreate those things. But you don't need to edit them. Okay. So in here now, I'm going to delete the test mirror vertical, not delete, but comment it out. And I'm going to uncomment the keep only blue. And then let's see, do I have a keep only blue tester file? I don't. So this call has nothing to actually refer to right now because it hasn't been defined yet. So I need to create the tester method for the keep only blue. And I'm just gonna, again, borrow from the 0 blue method, tester, and change it to keep only blue. So instead of testing 0 blue, I'm going to test keep only blue. Just a bunch of changes. And so 0 blue changes to keep only blue. And once I've done that, now I can basically run it, and I should see that instead of the image turning green, it should turn very blue. You'll see shades of blue, but and again, it will give us one copy as previous, like the original. Then it will make another copy, and there it is, only blue. So I'm going to give you a few minutes to try to get that worked out while I put the attendance in. All right, let me ask your help here. While I was talking, did anybody happen to see Colin, Aaron, or Ryder pop in and possibly out again? Because I know I did hear some dropping sounds from the Zoom, but I can't recall because there's 3 people who are not here currently. I can always go back and check later because I have a record of who signed in and who signed out, but for me to put the attendance in now, if you happen to have seen either Colin, Aaron, or Ryder, let me know. Then I won't mark them absent now. Thank you. This is our last virtual Monday for those of us who go in to school. Right, I guess after spring break, we come back and that's when some folks will be returning to the 5-day a week in school schedule. Okay, so how's it going? Does anybody have any questions or problems getting the either the test 0 blue or the keep only blue to work? Joey?
Whenever I hit run on mine, it just stops running, like after a little bit, and I don't really know why.
Is it like scrolling or?
Well, it will like run for a little bit, and then it will just flash back to like the stop button, or like it will go back from saying stop to run. So
Oh,
like it resets.
and nothing happened.
No.
Okay. So let's go through one thing at a time and compare. In your main.java, have you commented out everything except for line 17 and 18? Okay. Then in the picture tester, you have in the main method, just that one line is uncommented and the rest is commented. Okay. So then let's just try, like, did you get the test 0? You didn't get the test 0 blue working, even that on its own?
I had the test 0 blue working when it would turn like green or whatever.
Yeah.
And then for the only blue, you said to set red and green to 0 for that, right?
Right. So the only change we made, we kind of just copied and pasted this. So let's go to the picture class where that, did you change all of these? Make sure that any place where it said 0 blue for the runner method, you change it to keep only blue. Basically 2 places there and then the comment. Then in picture, just make sure you have the same thing as 0 blue, except for the pixel object, you do dot set red 0 and pixel object dot set green 0. Make sure capitals for the red and green. And both of these are inside. You've got, matching brackets and everything. Make sure you do not have a semicolon at the end of any of your for loop headers. Although that would not cause infinite loop or anything. It might just make it not do anything, though.
That is why
What?
I'm still kind of confused. I thought I'm pretty sure I have that also. I mean, obviously something small is wrong along the way. Or else
Okay.
it wouldn't be.
All right. Let's see. Maybe you could. By the way, anyone who's got it working, feel free to go ahead and try the next exercise. But let's see. Joey, maybe I'll stop sharing and you share your screen with us.
Okay. So like when I run it,
That looks
runs
good.
for a little bit and then it just stops. Like now it says run again.
Okay. Okay, scroll up to the test 0 blue and test keep only blue. That looks good. All right, let's go back to picture.class or Java, picture.java.
Is it picture.class or?
No, sorry, picture.java. Let me just compare. Yep, that looks the same as mine. Okay, go back to main. All right, how about this? Refresh your browser, just a little, maybe some changes haven't been included in your compiled version.
I'm still doing it. Should I just move on for now and then?
Well, if you can't see any output,
I don't really know
it's
what I
not-
would have commented or uncommented that could have caused that though.
Yeah, I mean, it
Should
seems like everything looks the same, but
I redo
as you
it?
were looking through the files, like, did you spend time reading through and looking at different things and perhaps accidentally delete something that
I don't think so. Should I just restart it and then do that again?
Yeah, I mean, like, if you want, you could just kind of refork it from my copy and then just make those changes again. It doesn't take long, right?
All right, thank you.
And see if it works back at the original version. That's frustrating. Okay, well, let's see what's next. Exercise 4, write the negate method to negate all the pixels in a picture. That means to set the red value to 255 minus the current red value. Set the green value to 255 minus the current green value. So this is like flipping them to the like opposite value, and do that for the blue as well. And then of course you create a static method to test that method, just like same process we went through. So this is going to be called negate. I'm going to start with actually writing the negate method in the picture class. So since it's again going to go through every pixel and do the exact same thing to every pixel, I'm going to borrow the outline of my keep only blue method again and just change it. Method to negate each pixel. Okay, so this is going to be just called negate. Now, we're basically going to be setting each pixel's red, green, and blue values to something new. But we're not setting them to 0. We're going to set them to whatever they currently are subtracted from 255. So 255 minus, and then basically I want to take whatever this pixel is, pixel object, and get its red value. Subtract that from 255 and set its red value to that new amount. I'm going to do this for the get red, get green.
I don't think you're screen sharing.
Oh, sorry, get blue. I'll show you in a second. Here we go. Back to screen sharing. Thank you. All right, so under keep only blue, I just copied and pasted the same structure of a set of nested loops. And Maxwell, I did get your message just now that your computer was frozen. Is it your whole computer or just the replit?
The whole thing.
The whole thing. Oh no. Well, I am recording this lesson. I always do. So if you can't get your computer working now, but later on you could go back through it and you want to watch, I can send you this recording if that would help. Are you working on a school issued Chromebook or you have your own device?
The Chromebook was a bit limiting before, so I switched.
Okay. Have you got anything back up and running or?
I'm just waiting for it.
Okay. Well, I'm going to leave this here for those who are working on this next exercise with me. So we're defining a new method to negate each pixel. We're using the same nested loop situation, but for the red part of the pixel, we are setting it to 255 minus whatever it currently was. So we're just getting it, subtracting it from 255 right there. Red, green, blue values are always values between 0 and 255. So we don't have to worry about it becoming a negative or anything like that. And so once you have the negate method defined, you're going to want to go to the picture tester class, I'm sorry, .java, and add in there a tester method to, create an object, send it giving it a image file, then call the negate method on it and then show it again. So that's where I'm going to head next. Picture tester. As far as I can tell, there is no negate method tester defined here yet. So I'm going to add that in after my keep only blue. And I'm basically, again, going to borrow the structure, but change the name of the method. So instead of testing my keep only blue method, I am testing my negate method. And what picture do I want to negate? I could change this to something else if I wanted to. I'm just going to leave it the beach. But instead of keep only the blue, I'm going to negate. And still show the original image in the Explore window and then negate and then show the new version of it. Okay. Now, this is not going to run yet because I don't have a call to the test negate method down in the main method of the picture tester file. So I still need to put in here, and I'm going to comment out the test keep only blue. I'm done checking that one. I'm going to call test negate. So this call will kick off this method up here, which will create a picture and call the negate method from that picture class. Now I'm supposedly running, but it takes a while, so I'm going to be patient and wait. Oh, here it comes. There's the beach. And there's the negated beach, which it looks really not, it looks almost otherworldly. That's the negative. I don't know if any of you have delved into photography as a hobby or anything with a film camera, an old style film camera, but when I was your age, we would only had film cameras. We didn't have digital cameras. And so when we would take pictures, we would put the film roll into a little envelope and we would send it in to get developed. And along with the regular picture, we would get back the little film negatives, which look like this. So that in case we ever wanted to, I guess, reprint the picture, you could hand in the negative and say which picture on there you wanted to have printed for you, and they would not have, you know, they don't keep the original film, they have the negative. So this looks just like a negative. We had to wait like 2 weeks for our pictures to get developed. So you try to take a selfie, I have no idea how people are going to look in it until 2 weeks later when it comes back. There was like a great deal of anticipation when a set of pictures was like developed. You came back from camp and you had taken all these pictures and you had no idea, you forget what was on there. You like, you know, go to the little kiosk. They used to have these little buildings in the middle of parking lots, like, because it didn't take a lot of space to have people drop off. It's called Photomat. You just like drive up, grab an envelope, stick your film canister in there, you fill out the form, leave it there, and like 2 weeks later, they, you know, you come back and check. And we would just drive up and keep checking because we were never sure if they were done yet. Kind of like a prescription at the pharmacy, but there was no way to register like your, you know, phone and have them call you when it's ready or anything. Anyway, so this is the negate method. I'm going to look back at the student guide and see what's next. Grayscale. Ah, see, this is starting to feel a lot more like filters on Instagram, right? If you can go through the whole picture and change something just by changing the colors of the pixels. So write the grayscale method to turn the picture into shades of gray. Set the red, green, and blue values to the average of the current red, green, and blue value for that pixel. So add up all three values, divide by 3. Create a, and then of course, go through the process of making a tester so that you can run it. Okay. So grayscale. That's next. I'm going to do set up the tester while I'm here because I'm here, and rather than flip around a lot, I'm just going to make my test grayscale method. And so let's see, we would be calling this grayscale. I'm just going to keep it all lowercase as a method, grayscale. All right. Then in my main method, oh, they already have a call to test grayscale, even though it wasn't defined yet. But I'm going to comment that out. Now it should be ready to run once I define the grayscale method. So going into picture, going to once again borrow the structure that's already written for traversing the entire 2D array, but this time I'm going to change it to grayscale. I can't decide whether I want to call it G-R-E-Y or G-R-A-Y. I'm going to go with whatever they put in here. Grayscale with an A. Okay. So the name of the method is grayscale. Now, I am going to have to get the red, green, and blue values again so that I know how to set the color of the pixel, but I'm not going to set them each individually. Okay. For this one, I'm going to create a temporary variable called sum, and also average. Now, you could make the average a double, because when you add integers together and you find the average of them, chances are the average is going to be a decimal, but pixel values don't get into decimals, so we're just going to take the average truncated as an integer. Okay. So as I go through the arrays for each pixel, I'm going to get the red, get the green, get the blue, and add them all together, put them in sum. Okay, so pixel object dot get red plus get green plus get blue. And then I have to find the average by dividing by 3. Could you just use one variable for this? You could start off with average, just adding up the values and then dividing itself by 3. Yes, but I like to have variables that are meaningful at all times. And so when I add the 3 things together and put them somewhere, I want that to be like stored in something called sum, not average yet. So it's really a design decision at this point, how you would manage those temporary variables, but this is just going to be the sum divided by 3. Now, so now the variable average contains the grayscale average of the red, green, and blue values for that pixel. And I'm going to have to set the pixel color to have that as its red, green, and blue values. So at this point, we could do pixel object dot set red to average and pixel object dot set green to the average. And set blue to the average. I think that should do it. So I'm just going to try and run. See my beautiful blue, grayscale beach, which you would oftentimes call this black and white, but technically it's not fully black or white. It's just grayscale. There you go. All right, how are we doing? Who needs help? Anybody? I'm tempted on one of these to do a traditional for loop instead of these for each loops, but actually the mirror vertical does that because it has to work with the individual pixel row and column a little more than just setting the whole pixel object. So, I mean, we could modify these just to get practice with traversing the rows and the columns using for loop, but since we had an easy way of just kind of copying the algorithm from the previous one, we'll just kind of stick with that. So the next challenge is pretty interesting. It says explore the water.jpg picture in the images folder. Let me see, do we have water.jpg in the images picture folder? Water. Oh yeah, water. Okay, looks like this. It's an underwater picture of some reef and fish activity. Okay. Write a method called fix underwater to modify the pixel colors to make the fish easier to see. Create a class, of course, all that setup stuff. Okay. So fix underwater. There is a hint in the teacher guide that says the way to fix it is basically to enhance the red, because underwater, the water filters out some of the colors of sunlight, and so everything looks blue. But if you can just enhance the red for every pixel, you will see more of the original colors of what's actually there under the water. So that's what I'm going to work on next, exercise 6. We'll see if we can get this done before the end of class. I want to go back to picture tester to set up myself to be able to test out my new method I'm going to write. I'll put it right here after grayscale, just kind of continuing. I'm going to test a method called fix underwater. And this time we're going to do it on the water file. So I'm going to change this from beach to water, and I'm going to call the fix underwater method. And they already have a call to the test runner, fix underwater, but now we need to write the fix underwater method itself in the picture file. So method to enhance the red in each picture so we can see the fish underwater better. All right, so basically I'm just going to go through all of this one's pretty simple as long as you know that hint about enhancing the red. It's just like, keeping only blue or whatever, or zeroing out the blue, except you're going to set the red to something more strong than what it currently is. So I'm going to borrow the structure one more time from one of the other methods, not the header, just the body. And instead of setting blue to 0 here, I'm going to set the red to something greater. Maybe we'll try doubling the amount of red. But if we're going to do that, let's say red is already, we'll just try doubling it as it is and see if it works. And we'll see how far we can push it. Okay, so we're going to do the pixel object get red so that we know what its current value of red is. And I'm just going to multiply that by 2 and see if it looks better, if I can see the fish better. And use that to set the red of that pixel. And we go through every pixel. I'm waiting for the compiler to do its thing. Currently, it's still showing the beach. Okay, here's the underwater image originally. And it's hard to tell which one is the original, which one is the, although it's on top, the new one's on top. I can see the fish a little better. Let me try multiplying it by 3 and redo that. Just rerun it. Here comes the original and the enhanced. It's a little better, not that great. I wonder if part of the problem is if you try to set the red color without testing if you're going over 255, you may end up defeating, like, it. I'm trying to think about that. If we multiply by 3, let's say it was already 100, and we multiply by 3 and we try to set the red to 300, what is it going to do with that? So I think I might look at the pixel class and see how does it handle setting the red depending on what I give it. So set red, where's set red? Really, I could just look at any of the colors, but There must be a set red. There's a get. All right, correct value. Oh, yeah. If the value we send into the set class, it's going to be run through the correct value method. If the value is greater than 255, it'll just set it to the highest value, 255. Okay, so it handles that. So this is as much red as we can get into the image. I think I remember doing this same algorithm last year, and when I set the red to multiplying by 3, it was a really much more distinct difference between the two. I'm not sure why it's not showing up as distinct. Does anybody else have it working and changing, and you can see a really much better version? All right, well, anyway, that is supposed to be the exercise 6 for activity 5. Then we move on to activity 6. And oh, we only have 1 minute left of class. So here is the mirroring pictures activity. Now that you've seen how you have to go through and create the method in the picture.java file, then you have to go into the picture tester class and create the tester method and then create the call or uncomment the call to that method. I would like you to try activity 6, exercise 1, okay? Currently, there is a mirror vertical method that I showed you how it works with the caterpillar. You want to study that method and try to figure out how it's working so that you can modify it instead to mirror vertical from right to left. So instead of taking pixels from the left and putting them over to the right, you're going to do the opposite. Okay. And there's a hint here. You can copy the body of mirror vertical and only change one line of code to accomplish this. So with that hint and studying the mirror vertical, try to do exercise 1 and let's just say exercise 1 and 2, make that your goal for homework. Mirror vertical right to left instead of left to right, which is what the current algorithm does. And see if you can get it to mirror horizontal from a line across, be able to take from the top and bring it down to the bottom. All right, so that's all we have time for today. I'm going to let you go and hope you have a great day, and we'll talk about these again on Wednesday, when I see you then. Okay? Bye.